Okay. Good morning, everyone. Happy to see you in our recitation, in our probability course. Okay, my name is Igor. I am your recitation teacher. Let's talk about the course, about homeworks, about the site, and let us start. Probably meeting. Okay. So, as I said, my name is Igor. I can help you in recitation, homework submission. If you have any question, you can ask me before lesson, after lesson, or we can talk at Zoom. Okay. A couple of words about our course. This course is very, very important, but it's also hard. Probably very hard. It depends. It depends on your background. If you're from mathematics or computer science, probably it's easier. If you're from economics or something else, probably it's harder. But this course is very, very important. Okay. This is a basic probability. And it's important to understand machine learning, statistical analysis, stochastic processes. It's a very, very important compound. But it's hard. What does it mean it's hard? You need to study. You need to read the lecture materials, recitation notes, to solve exercises, to ask AI for help, to help you to understand material better. This course demands time. It's very, very important, okay? And if you hate mathematics, it can be a bit tricky. Okay? Anybody hate mathematics? No, not yet. Not yet. Oh, good. Okay. So let's look at our site. Here, I will publish our homework submission. As you can see, here you have assignment 1. Here you can submit your homework. I will explain you all what you need to know. Also, I try to record our recitation at Zoom. So if you ill, you can participate via Zoom. Okay, if you're ill or you're in duty or abroad, you can also use Zoom if you want. It must be automatically or half automatically, yes. Okay. According materials, what we have here, we have recitation notes. Yes, we'll use these recitation notes. You have here, now I uploaded it yesterday, assignment number 1. And you need to upload, to submit your homework here, assignment 1, submission box. Okay, you will type your homework in LaTeX. Okay, here we have explanation how you can do it. You can convert your LaTeX file to PDF, and you will submit PDF file. And today it's not a big deal as it was, because you can use AI, you can ask him question how I convert my homework to LaTeX, who can explain you. So it's not a big deal. It's not very easy, but it's easy, okay? So submit your homework using LaTeX. You can read explanation how you can use LaTeX, yes. But I think AI in this field, in English, in mathematics, in LaTeX, very, very good. So we can. Okay. In addition, I publish every week quiz. You don't need to submit it, but we recommend you to do it. The quiz is very basic. It has very basic questions, but it's good to remember the material, to review the material. So our advice to do a quiz, okay? It's have 15, 20 simple questions, but it's not so simple. If you don't know material, it's not simple. If you read the lecture notes, it's simple. Okay? So we advise you to do also the quiz. It's for you. To have here. Okay, in general, that's all. Yes. Coding homeworks, assignments. It's very important part of learning, of study. Yes. Everyone need to do homework because this is part of learning. It's not for us, it's for you. Okay. You can ask AI or internet for help, but don't use it as blind solution. Yes. Don't ask solve this question for me and submit it. It's not the way to learn. If you want to learn, you need to try to solve the question, try again, ask your friends, yes. And if you can't, you can ask help about AI or ChatGPT or I don't know, in internet, but always you need to understand solution and you need to study from it. Okay, it's very, very important for you. Because in exam, you don't have access to ChatGPT, and okay, so it's not a good idea to copy paste solution from ChatGPT or from here. It's clear? Okay, excellent. So what we do today, we will talk about material from the previous lecture. And we will solve a couple of exercises, and you will need to submit homework number 1. We will check homeworks randomly, but I will publish your solution. Okay, so your goal is to check solution against my solution against your solution. Okay, and we will check it randomly each week for some people. Okay, because so many students now, it's possible to check. If you don't have enough time to submit 1 homework or 2, it's okay. You don't need to submit all homeworks. Let's say we will have 10 homeworks, let's say. It's enough to submit 8. So if you can't submit 1 homework, don't ask me for delay, don't submit, okay? But in general, from 10, you need to submit 8, something like that, -2. And our advice to try to submit every homework. Okay. Questions? Yes.
How we can contact with you?
By email or in the class after the lesson or before the lesson.
What's the reason?
How you want? You by Zoom, by email. How you want to call?
No, but what is your email?
Email. Okay. Yes, I think it's here in the syllabus. It's a good question. Good question. Let's see. Yes. Where is it? You see, it's my email.
Oh,
Yes, by email.
okay. And each assignment, for how long we can submit it?
10 days, something like that.
Okay.
Okay, thank you for your question. What question? Additional questions? Okay, if you can interrupt me and ask. Yes, it's always welcome. Okay, so let's start from recitation number 1. Let's try it. It works. Yes, okay, nice. Yeah. Okay, pay attention to the material. It's not very interesting. It's not machine learning. It's not algorithms. Yes, it's theory. It's basic theory, but it's very, very important to understand the basic of probability. Sets, probability space. I know it's boring. It's hard, but it's important. If you want to know probability well, if you want to know statistics well, you need to understand. Yes, there are no ways for kings in mathematics. Yes, this expression. There are no ways for kings. There's only ways for workers. Yes, for hard work, for us. Okay, so today we'll talk about very basic definition of set operation, identities, probability space probably, and sample space and signal fields. Okay. Okay, here you can see a kind of review or reminder about sets notation. Assume you probably know this from discrete mathematics course or probability 1 course from your previous study. Yes, we can use this notation during all the course. Yes, capital omega is a sample space. Yes, it has all possible outcomes of our random experiments. We will talk about elementary event, omega, small omega. It's a member of capital omega. We will talk about complement of set, intersection, union. A is a subset of B, and also we'll use empty set. Empty set has no one element. Yes, it has 0 elements. It's empty set. Okay, do you know this notation? Do you think? Yes. Yes.
Just there's one omega at the top and omega at the bottom.
Yes, it's the same. Yes, yeah, this one at least. Yes. Sometimes we call to this omega whole space or sample space, yes. Or universe. Sometimes we call to this.
But a certain event, like it's sort of a.
It's also a certain event because in your random experiment, you always will get something from omega. Yes. Okay. Also, we'll use many identities. Probably you know some of them from previous courses. There are many of them. They're only part of all possible identities that we can use. Some of them are very trivial and some of them not. Yes, for example, commutative law states that A union B equals B union A. Yes. A intersection B equals B intersection. Yes, there are many identities. You can see the associative law, distributive law, and also it's less common, but also important, the Morgan laws. It has two forms. Is it just a moment? It has two. No. Okay. Okay. Not perfect. Okay. It has two forms. Complement of A union B equals complement of A intersection complement of B, and the second form. Sometimes we'll use the Morgan law. When we want to use it, if we want to move from union to intersection or vice versa. Okay. Do you remember these identities? Yes. You don't need to remember this, but you need to know how to use it. Yes. You can open book and okay. So let's start some exercises. And here I need to say something. Our course is mathematics. Yes. In general, it's mathematics course. So you need to study, if you don't know how to prove your statement in mathematical way. Okay? You can to know how to prove your statement. And I will demonstrate you, and Yuri or Ori will demonstrate you how to prove statements. And it's very, very important. I suppose we have students from mathematics, computer science studied that in the previous degrees, but probably also in other departments you studied. But it's very important to understand how prove statements. And it can be hard. It can be hard. And the way is to see examples. So let's start. Let's start. Okay, here we have some basic statements, not from probability, it's set from set theory. We want to prove the Morgan law. We want to prove that these two sets are equal. Complement of A intersection B equals complement of A union complement of B. Pay attention. You can provide example of this statement, yes? Because example is the only partial case. Probably there exists another example such that for that example, this statement is incorrect. So you can prove this statement by example. Yes, you can check, but you can't prove. You also can't use drawing to prove this statement. Yes, some people try to prove this statement by drawing. Yes, suppose this is our omega, yes, sample space. This is A, this is B. And where is the complement of A intersection B? It's all of these, yes. Just a moment. Yes. Except A intersection B, except this small part, yes? This is complement of A intersection B. You also can try to draw this part, right-hand side. What we have here, complement of A, union complement of B, yes? And if you will try, you will get the same picture. You will get this. So we get two identical pictures for left-hand side and for right. Does it prove? No, it's only intuition. It's not a proof. Okay, for intuition, you can make this picture. You can draw it to understand it's better, but you can prove mathematical statement using picture. So it's not a proof. It's only intuition.
Yeah, and sometimes it's helpful if you draw the picture to kind of keep track of every step you take.
Yes. It can help. Yes. It can help. And sometimes it can provide you counterexample. Not in this case, but in general. Yes. You're right. Okay. So we need to prove this statement. Oh. How we can prove in mathematics that two sets are identical? For example, we can use this rule. Set A equals to set B equals set B if A is a subset of B and also B is a subset of A. This is mathematical property. Yes. If every element from A belongs to B, and every element from B belongs to A, then A equals B. Make sense? Yes. So we will use this property to prove this statement. So, and now pay attention, the proof is, it seems very obvious. It seems not very interesting, but I remember when I studied this proof many years ago, I even don't understand it because it seems so simple, so you don't understand what's the idea of this proof. But it's correct, it's basic, and it's important to understand it. So let's try. Okay, space. Let's try that to work. Okay, not this guy. Yes. Okay. So first step, we want to prove that this set is a subset of this set. Yes. How we can prove it? We will take some element, any element from this set, and we want to prove that this element belongs to this set. Yes. Okay. But which one element? We don't know. Yes. So let's give him a name as a baby, X. Let's take some element X from the left set. And our goal is to prove that X belongs to the right set. Okay, let's try. Okay, suppose X, some element from a complement of A intersection B. By definition of complement, pay attention, this proof based on definitions, only on definition. If X belongs to complement of A intersection B, then by definition of complement, X does not belong to A intersection B. Make sense? It's the same. If X is not in A, where is X? In complement of A. So if X is here, then X is not here. Why? This is definition of complement. Make sense? Yes, it's easy steps. Okay. Now let us use definition of intersection. If X does not belong to intersection, then X or not in A, or not in B, or not in both of them. Okay. So by definition of intersection, that means X is not member of A, or X is not member of B, or both. Make sense? It's also very easy transition, yes? Okay, but if X is not member of A, by definition of complement, X belongs to A complement. Yes? If it's not an A, it's in A complement. If X is not member of B, by definition of complement, X belongs to B complement. Make sense? So now we're here. We know that X belongs to complement, or X belongs to B complement, or both of them. But by definition of union, we can conclude that X belongs to complement of A or complement of B. That's all. That's first part. We took any X from this set, and we prove that in this case, X will belong to this set. So we prove that left set is a subset of the right set. That's all. Does it clear? Does it hard? Does it easy? Depends. It depends. But you can see this is very formal proof. It's very formal proof. It's not very interesting. It's not very motivating. Yes, but this is formal proof. In this way, we can prove state, for example. It's not the only one way. Yes, there exist many ways, but this one. Okay. Any questions? Oh. Now we need to prove second direction. It's similar. No. Okay, not here. Just a moment. Okay, it's not here. Okay, second direction. It is very, very similar. Now we took some element from the right hand side. Yes. Okay, we change here. So we need to prove that A is complement. Yes. Yeah, from here. We take x from this right hand side. From this right hand side, yes. From this subset, and we want to prove that x belongs to this set. Okay. If x belongs to complement of A union complement of B, by definition of union, x belongs to complement of A, or x belongs to complement of B, or both. Make sense? Now we can use definition of complement. If x belongs to complement of A, when x does not belong to A, and in similar way, we have here x does not belong to B. Where here, make sense? X does not belong to A, or x does not belong to B, or both. It's clear or not? So wait. But if x not belongs to A, not belong to A, or x not belong to B, by definition of intersection, x does not belong to A intersection B. Yes. If it's not here or here, it's not belong to intersection. But by definition of complement, if x is not here, then x belongs to complement of intersection B. And we prove the second part. If x is a member of this set, then x will be a member of this set. So we prove inclusion to both directions. And this is the proof. Let's see, inclusion, yes. We prove that A complement A intersection B is such this guy, and complement of A union complement of B is a subset of this guy. So these two sets are identical. This is standard proof. Yes. You will solve something very similar in your homework. Yes, you don't need to be expert in these proofs. Usually students prove it in the discrete mathematics course in first degree, but at least you need to see a couple of examples. Okay, so this is formal mathematical proof. One of the proof of this statement. Questions? Okay, if you don't understand it 100%, you need to read it again, to probably need to ask ChatGPT or something. But this is kind of things that we will use in our course. Questions? Yes.
Second line.
Part one or part two?
Part
Two. Mhm.
X belong to A complement union B complement.
Mhm.
Then therefore that means that X that it belong to A complement.
Or B complement or both?
Because we use it twice. When we use the intersection to pass it up. No.
No, intersection it's end.
Yeah, I got it.
Yes.
Yeah.
Good. Go. That's all.
One more question.
Just one.
Can you write? We write it with if and only if symbol.
Sometimes, yes. It depends on the proof. Yes. Okay. Here, yes, but it's not in every exercise.
So for the second line, of the first part,
Yes.
so by definition of intersection, not second, see, one more down.
One. This.
No,
This.
down, by definition of intersection,
First of all, by definition of complement, if x is here,
yeah,
then x is not in A intersection B.
yeah,
And now, by definition of intersection, if x does not belong to A intersection B, why? Or x is not in A, or x is not in B, or both.
yeah, so when we say both, like, because we said X is within, so X is not in, so X is in the, X is not in the intersection of A and B.
Yes.
Yeah, X is not in the intersection.
A or x is not in B.
Yeah.
And
Okay,
sometimes you don't need to add this because we understand it.
yeah, no, never mind, I got it.
Okay. Additional questions? Okay. So let's continue. Yes. Okay. Okay. Similar question, but I want to show you another way to prove this statement. Again, we have here two sets. This guy is a set, and also this fellow is a set. And we want to prove that they're identical. You can use the way we used in the previous exercise, but I want to demonstrate you other way how you can solve this question. Usually it's many ways to solve question in mathematics. Some of them are easier, some of them are harder. Okay. Here, I want to show you how we can use identities to prove this statement. Okay, let us use identities. And this is reminder about identities. Where is it? It's here. Yes. Commutative law, associative law. Let's use it identities. And pay attention. When I demonstrate you solution, you can ask me, or you can think in your head, how he knows this. Yes, how he built this solution. Okay, it's hard work to build mathematical proof. Is a hard work. Man need to see, to think, to try something else. It can take many hours. But in our lesson, I can try to solve question. I need to present you solution because we don't have enough time. But in general, if you need to want to solve some question, it can take many hours. Yes, in general. But in class, we don't have enough time. So we only look on correct solution, one of them. Okay. Okay, let's start. Okay, we start from the left guy. We will use identities and we will get finally the right fellow. Okay, what we have here? Complement of A as union. And here in the brackets, we have B intersection C. Okay, let's start. Distribution, yes. De Morgan, also De Morgan, yes. Yes, okay. Let's start from De Morgan, and after that we can use distribution. Yes. Okay. Okay, we start from the left fellow. Can we use here De Morgan law? Let's start.
Yeah.
Yes, just a moment. It's not so good. Yes. Here we can use De Morgan law. Complement of something union something equals to complement of left side, intersection complement of right side. So let us use De Morgan law. By De Morgan law, we get this expression. Okay, this is a new set. It equals this set. And also pay attention to explanation. You see, in your exams, in your homework, you also need to write explanation. It's very important, especially in exam. When Ori checks your exam, he not only look to solution, he also look on explanation and explanation. So it's very important to write explanation. Okay, explanation is something brief. You don't need to write very long, very many sentences about something simple. De Morgan, it's enough, according to De Morgan. So, okay, next thing. There are many ways of how we can continue, but let us use De Morgan here. Can we use De Morgan here? Yes, again. By De Morgan law, this fellow equals complement of B union complement of C. Okay, pay attention. This fellow, this guy, similar to this guy, yes, but not identical. We need to change these two fellows, interchange, and also these two guys. Okay, we can use, what is it? If we want to just a moment to change it order, we can use, for example, commutative law. Probably we also need commutative law. That's it. Commutative law, yes. We can use these two statements to change order between intersection and union. Make sense? Okay. Okay. Not here. Okay. So, okay, we do this. by commutative law for intersection, we get this expression. Complement of B union complement of C, intersection complement of S. Okay. It's clear? Yes. What is the next step?
That's it, you know?
Again, we need to use commutative law here. Okay. By commutative law, just a moment. We get this. And this is our goal. Yes. So using the identities, we prove that the left side, left statement, left set equals right set. That's all. And I think you have something similar in your homework to try. Okay. It's something very basic. It's not something profound, but it's important to understand. Because probability built on set theory, on measure theory, on set theory. Okay. Okay. It's clear? Can we continue? Okay. In our course, we will work not only with finite unions of sets or finite intersections of sets, we will also talk about infinite unions of sets or infinite intersections. Not two sets, three sets, infinitely many sets. Countable infinitely many sets. So in this exercise is a simple exercise. We define infinitely many sets, A1, A2, A3 until infinity. And we want to find their unions. If you want, also can find the intersection. Okay, so let's try. Okay. Just a moment. Probably I'll use this. Okay. Okay. Okay, it's also not hard exercise, but it's important to understand the ideas. Okay, we have infinitely many sets. A1, what is A1?
1, 2,
2, yes, it's in the natural numbers without zero. What is A2?
starting from 2.
Starting from 2, yes, it's 2, 3. Just, no. Okay. Okay, it doesn't work here. Let's try here. Okay. A2 is 2, 3 until infinity. And we have A3 and 4 until infinity. And our goal is to find union of A1, A2, A3, also until infinity. Yes? Okay, now we need to guess and to prove what is this set. What do you think?
That's all.
Exactly, without zero, yes, yes. Why?
A1 is contained in all
Yes, okay,
2.
yes,
So
yes. Pay attention, in this special example, if this is the A1, then A2 is a subset of A1. Does it clear? And A3 is a subset of A2. And A4 is a subset of A3, and we continue the same way. We have a decreasing sequence of cells. In this case, what you can say about union of all of them? It's a larger set. It's a one, yes. If we have a decreasing sequence of cells, the union is A1. But A1 is all natural numbers except 0. So in this case, you can say when this set equals to A1. But we need to prove that. Yes. It's only our guess. So here we have a guess, intellectual guess, that this union equals to A1 or equals to this set. And now again, we need to prove this statement. It's not enough to say some. We need to prove it. And again, you see here we have equality, yes, between two sets. So we need to prove in some way, in some mathematical way, that these two sets are equal. Okay. Okay, how we can prove? Let us prove. So, okay, let's denote it by B and this by C. So want to prove that C is a subset of B and B is a subset of C. And it's enough.
Why we denote that C?
Last time.
One.
Okay, it's also a one. That doesn't matter. It's notions. In mathematics, you can freedom how we can denote things how whatever we want. But it's a yeah, you so here we have two sets, and we want to prove B equals C. It's enough to prove that C is a subset of B and B is a subset of C, and as you said, C is A1. Yes. Okay, let's write it. Yes, it's A1. How you can convince me or yourself that A1 is a subset of B? Let's put it. Does it? Why A1 is a subset of B's guy?
Because A1 is including in the union.
Yes, it's a part of a union. Yes, it's a definition of a union. Elements belongs to union if they belong to at least one of them. And A1 is here. Yes, it's union of A1, something else, something else. So this statement is very, very easy to prove. Now we need to prove that D belongs to C, to A1. Okay, there are many ways to prove it. For example, okay, let's choose some X that belongs to B. Yes, some unknown element X belongs to B. Okay, if X belongs to B, then X belongs to at least one over A. What is his name? AJ. I know. But if it belongs to AJ, for some J, it also belongs to A1. Because A1, all of the set belongs to A1. So it belongs to A1. So if X belongs to B, X belongs to A1. That's all. It's very simple exercise. It's a very simple exercise.
Prove that A2 is the subset of A1.
Yes, yes, yes. Every A is a subset of A1.
We have to prove that.
You need to explain it in one sentence. Yes.
So it's just like, I'm confused. So the first step we said, so this C, right, which is 1, 2, 3 until I, for
C is A1. Yes.
yes, that's A1. So I'm just not like, what do we say to show that A1 is a subset of B? Like we just kind of
Because it's definition of a union.
definition of a union is like
Element belongs to the union if it belongs to at least one of elements. Yes.
okay, yeah.
So you can write it more detailed. Pay attention. Okay, good question. Pay attention. Let's take some X that belongs to A1. Yes.
Yeah.
C is A1. Yes. If it belongs to A1, by definition of union, it's here. Because it's union A1, A2, until that's all. What do you think about intersection? What do you think about intersection? Of all of these sets. That, yes.
And the smallest A, let's say A infinity.
But what does it mean? What do you say?
The smallest set.
Yes, but what is it?
A infinity in this.
Not exactly. Empty set. It's empty set. Okay, let's try to think about intersection. Does one is an intersection? No, because one belongs only to A1. So one is not intersection. Does two in intersection? No, two belongs to A1, A2, but does not belong to A3 and 4 until 2 is not also an intersection. Does any natural number, million, in intersection?
No.
No. So we can prove for every natural x, for every, it's not belongs to intersection. So intersection is empty set. Is empty set. Okay. It's clear? Just a moment. I want to prove this statement. This is last statement for today. Okay, to look with you on your homework, and we will stop here. Okay. What we want here to prove here? Okay, we want to prove equality between two sets. But left fellow and right fellow is an infinite intersection or infinite union of these sets. Please look of these statements of these sets. Can you see here something similar? It's kind of the Morgan law. Intersection of sets equals complement of union of complements. It's the Morgan version of for infinitely many sets. If you put this complement here, it's the Morgan law. Okay, and our goal is to prove this statement. And pay attention, we can draw here some diagram because it has infinitely many sets. We can build intuition by drawing it. We need to prove it formally. And the proof is very similar to our previous proof in the first exercise. It's very, very simple. Okay, let's start. It's enough to prove that this set is a subset of this set, and this set, the right one, is a subset of the left. So let's choose any x, some x, from this field. Okay, not x, omega. Doesn't. It's names. It's not important. Okay, let's choose some omega. That's a member of intersection. I goes from 1 to infinity. Okay. If omega belongs to intersection, then by definition of intersection, omega belongs to every f1. Yes. By definition of intersection, omega belongs to every. Okay, but we want something with complement. Yes, I have here complement. If omega belongs to fi, then by definition of complement, omega does not belong to fi complement. This is definition of complement. Make sense? So omega does not belong to fi complement for everyone. Okay, but if omega does not belong for every complement for any y, by definition of union, omega does not belong to union of them. Make sense? If it's not in f1, it's not in f2, it's not in f3, it's not also not in union of them. So omega does not belong to union fi complement. But by definition of complement, if omega is not here, then omega belongs to complement of this guy. by definition of complement. By definition of complement, omega belongs to complement of this term. And we prove the first step. This subset, this set is a subset of this set. And we need to prove the second direction. No, it's clear. What do you think about second direction? It's similar. It's very, very similar. You can it's in slides. Okay, before we stop, our time is out, but before we stop, let's look at homework. And after that, we will stop. Okay. According to your homework, I want to review it. Always try your best to do your homework. It's very important. Okay. If you stuck, ask AI, ask Google. If you continue to be stuck, you can ask me or Ori, but always try your best in your homework. Okay. The grade in homeworks is not important. If you try your best, you will get maximum grade. If you try your best. If you don't try, it depends. Okay, so let's look at homework number 1, assignment number 1. Okay. Pay attention. I use AI. I take my old homework notes and translate it to the site using AI. I checked it. I hope there are not errors here, but sometimes it can be. Okay. But in general, it's based on my notes, but you know, okay. So you need to submit your homework using this site, using Moodle. Okay, you need to provide complete proof. It's very important to you to study, to learn how to prove things in mathematics, in probability, in machine learning, algorithms. Justify every statement. You don't need to write long justification, but one sentence can be enough. According to complement definition, according to statement from the lecture notes, De Morgan, it's enough. Yes, you don't need to write very long explanations. Do you work in LaTeX? As I said previously, it's not hard today because you can ask AI for help and submit only PDF file, only one PDF file. Okay. Write proofs in complete sentences using logical connecting words. Okay. AI can be assistant, but it can replace you solve problems for you, as I said. Okay. What you need to do, read lecture notes 1. I hope you did it yet. Yes, you have read it. Okay. You also can read recitation slides. You can do quiz number 1 and these exercises. As you can see, here you have 1, 2, 3 sets, and you need to prove equality distance. You can use definition. You can use identities. You can also use other ways that we don't talk about sets, but you can. Okay, here you need to prove the Morgan laws, two versions of the Morgan laws. Pay attention, we have proved one of them, but you can do it again, okay, to how you remember it, or probably can do it in other way. It's also good. So one of what direction we did. Okay. Here you also have 2 statements about sets. Okay, here we denote sample space omega. Yes, we corresponded to 3 tosses of coin. And here we ask you to describe events ABC. Okay, it's an easy exercise. You need only to describe these events. And in the last exercise, you have some definition of indicator function. Okay, you need to read it, but it's not very hard. And prove 3 statements. Okay. Small comment. This function is very important function in probability. You won't see it in this exercise. It's only definition. But this definition is very, very important, very, very useful for probability and statistics. Okay. But in general, that's all. It's not hard homework, but it's good homework as starting point. So start from this, try your best and submit it. And I will give you a solution after that. Okay, that's all for today. Have you any questions? Thank you. I see you next week. Okay, good. Somebody in Zoom? No.